Hello everyone, welcome back. In this video, we'll be going over section 4.9, antiderivatives. All along in chapter 4, we saw a lot of information about a comprehensive graph. What do we mean by absolute maximum, absolute minimum? What do you mean by local maximum, local minimum? Then what is Rolle's theorem and mean value theorem? And where is the function increasing? Where is the function decreasing? What is the derivative test for that? And then when do you say a graph is concave upward? When do you say a graph is concave upward, downward, using second derivative test and so on? And then we also saw in the next section a summary of curve sketching by following some guidelines. And we also saw in one of the sections 4.7 how the analytical aspect of the calculus aspect of absolute maximum and absolute minimum, how they applied in real world problems in optimization theory. So there is so much applications and theory behind this chapter. And the last section of this is going to be the antiderivatives, which is kind of an intro to what you're going to see in the next two chapters, chapter 5 and chapter 6. So all of calculus 1 is divided into two. The first part is differentiation. The second part is the intro to integration. In the next level calculus class, you would see a lot more of integration. So when differentiation is all about tangent and velocity problem, and you will notice that the antiderivatives or integration is totally a different problem, which is the area problem. Okay, so it's such an interesting topic. A function f is called an antiderivative the uppercase f is called the antiderivative of the lowercase f on an interval I if the derivative of the uppercase f equal to lowercase f for all x in I. So this is the condition. If you differentiate this uppercase f, what you should get is the lowercase f. Then we say the uppercase f is the antiderivative of lowercase f. So what is this theorem? If f is an antiderivative of lowercase f on an interval I, then the most general antiderivative of f on I is uppercase f of x plus c. The most general antiderivative. If you use the word general, then you have to add an additive constant. So what it means is, suppose you differentiate your answer, d by dx of f of x plus c would be f prime x plus derivative of constant, this is equal to 0. Okay, so that is what we mean by, so what is f prime x, which is equal to f of x. So the derivative of the answer should give you the original function back, where c is an arbitrary constant. C can be any constant. Suppose you take y equal to x cube plus 3, x cube over 3 plus 3. You notice here, x cube over 3 plus 3. So if you take that function x cube over 3, which passes through the origin, and then plus 3 means it's a shift up 3 units, and then shift up 3 units, then shift up 2 units, the second one plus 2, then shift up 1 unit, then it is x cube over 3, that is the one that passes through the origin, which is x cube over 3, the pink one. Then down, it is -1 and -2. So this will be -1, this will be -2. This is 1, 2, 3. So you see that by changing the constant c, you get the shape of the curve is the same. It is just shifted up or down. It's a family of curves for different values of c. So find the most general antiderivative of the following functions. F of x equal to sine x. So what do we have to look for? So you have to get a value, you have to get a function back here. When you differentiate that function, you should get the sine x. So what is that function I want to differentiate so that when I when I get the function as sin x, what function I have to take. So when I differentiate that, I get sin x. That is what we mean by that. Because of the word most general, then you may have to add a constant c. So if I consider, let's consider f of x equal to negative sin x. So what happens when I differentiate this? So it is a kind of a check for us. When I differentiate, I should get the function back, which is the original function f, small lowercase f back. So if I differentiate this answer that I got, which is, sorry, here it should be negative cosine x. So if I differentiate this, I have a negative that can be kept out. And derivative of cosine x, which is negative sin x. So negative of negative sin x will be a sin x, which is nothing but the original function. So once you get an answer to the antiderivative, the way to check whether it is the antiderivative of the original function or not, differentiate your answer, then you have to get the function back. Okay, because it is general antiderivative, you have to add an additive constant. So f of x equal to negative cosine x plus c. That is the answer to the problem. Now, what is the antiderivative of 1 over x? So let's consider f of x equal to ln of absolute x. So we know what we mean by absolute x. Absolute x equal to x. Absolute x equal to x if x is more than or equal to 0. Absolute x equal to negative x when x is less than 0. So how do we know that our answer is right here? So let's consider f prime x. This is a check. You differentiate. If x was positive, it will be ln of x. So it will be 1 over x whenever x is positive. Whenever x was negative, ln of absolute x, absolute x equal to x whenever x is positive. Absolute x equal to negative x. So it will be 1 over negative x times negative 1. That will make it 1 over x also. So it is x less than, whenever x is less than 0. So what does this mean? So in both cases, you get 1 over x. So antiderivative or general antiderivative f of x equal to ln of absolute x plus a constant c. All right, third one. If f of x equal to x to the n when n is not equal to 1, what is the antiderivative? So let us consider this function f of x equal to x to the n plus 1 over n plus 1 when n is not equal to negative 1, because the denominator cannot be equal to 0. So how do we verify whether our answer is right or wrong? So if you differentiate f of x, so you'll get that to be 1 over n plus 1, which is a constant that can be taken out. Then derivative of x to the n plus 1, right? You have to take the derivative of that. So 1 over n plus 1 times, it is exponent times x to the exponent minus 1. That is n plus 1 get cancelled. So you get x to the n back, which is nothing but f of x. Here also we have to say this is nothing but the given function. In both cases, it is equal to f of x, right? We have to say that. So we notice that if you differentiate your answer, you get the original function back. That's a way to check. So general antiderivative of the function f of x, which is equal to x to the n, is x to the n plus 1 over n plus 1 plus an additive constant. So as I always say, C the C. Okay. Whenever the question is the general antiderivative, to C the C. You have to add that additive constant. All right. So what is antiderivative? So once you, there are lots of formulas you are going to learn. For this one, we are just understanding the concept of antiderivative. Antiderivative of a function, given function, is the function whose derivative is the original function f, lowercase f. So the antiderivative of a given function is an uppercase function f, whose derivative, when you take the derivative of your answer, you have to get the original function back, the lowercase function f in the answer. All right, so that is about antiderivative. So we have a bunch of formulas here, table of antiderivative formula. These are some of the basic ones, and you're going to see a lot more. If the function is c times f of x, what is its? So here we are not talking about general antiderivatives. So we are going to do the particular antiderivative. Particular antiderivative is one where we assume the constant to be equal to 0. So c times f of x equal to c times uppercase f of x. So obviously uppercase f of x is the antiderivative of lowercase f of x. And f of x plus g of x, the antiderivative is uppercase f of x plus g of x. Antiderivative of x to the n, where n is not equal to -1, is x to the n plus 1 over n plus 1, which is what we did in the previous problem, which is which is known as a power rule for integration. Antiderivative of 1 over x is ln of absolute x. Antiderivative of e to the x is e to the x. Why? Because if you take the derivative of your answer, if you take the derivative of the answer, which is e to the x, you get the original function back, which is e to the x also. An antiderivative of cosine x is sine x, because when you take antiderivative of, when you take the derivative of your answer, namely sine x, what do you get? You get this function back, which is cosine x. Derivative integral of sine x or antiderivative of sine x is negative cosine x. Antiderivative of secant square x is tan x. Antiderivative of secant x tan x is secant x, because if you differentiate secant x, you're going to get this secant x tan x back in the reverse order. So this order is, the given order is antiderivative. If you go the reverse order, you will get you're going to take the derivative of your answer, which will give you back the original function. 1 over square root of 1 minus x squared, which is antiderivative of that, which will be sine inverse of x. 1 over 1 plus x square, antiderivative is tan inverse of x. Then integral of cosine hyperbolic x is sine hyperbolic x. Antiderivative of sine hyperbolic is cosine hyperbolic. Okay, we'll do a problem based on this information. So so what we have to remember is that when you take a function and when you do the derivative, what you get is f prime. When you take one more time derivative of f prime, what you get is f double prime, right? So on the other hand, if you're coming from this direction, from f double prime, if you do the antiderivative, from f double prime, if you do the antiderivative, you get f prime. And if you do the antiderivative of f prime, what you will get is f. Okay. So if you go from f to f double prime, you have to take the derivative, first derivative and the second derivative. So if you are going from f second derivative to the first function, then you have to take 2 times antiderivatives. So find f. So you are given that find f. If f double prime x equal to 12x square plus 6x minus 4, and f of 0 equal to 4 and f of 1 equal to 1. So the question is, what is f given the second derivative? So we are going backwards, right? F double prime, if you do the antiderivative, you are going to get F prime, then F prime to F. Again, you are going to do antiderivative. All right, let's start with F double prime is 12x squared plus 6x minus 4. Then let's take the antiderivative for this part, which will give the first derivative. From the second derivative, if you do the antiderivative, you get the first derivative, which is 12, antiderivative of 12x squared. So 12 is a constant, which can be written as x cube over 3, because in the formula we know that antiderivative of x to the n is x to the n plus 1 over n plus 1. So x square antiderivative is exponent plus 1 over exponent plus 1. Plus 6, x to the 1, so x to the 1 plus 1 over 1 plus 1. Minus antiderivative of 4, which is x to the power 0, so it will be x to the power 1 over 1. Then we have to add an additive constant, we'll call it C. So f prime x equal to 4x cube plus, this is equal to 2, 2 goes into 6 3 times, 3x square minus 4x plus C. Call it 1. See, at this step, if we know f prime of a number, then we can find out the constant C immediately. So we are not given any condition with regard to f prime. We know only conditions with regard to f. F at 0, f at 1. So how do you interpret the initial conditions here? F at 0, when x equal to 0, y equal to 4. When x equal to 1, y equal to 1 also. That is what it means. So it is about the input. Input equal to 1, input equal to 0. The output is corresponding to 0, the output is 4. Corresponding to 1, the output is 1. So now we will do one more time antiderivative. So we are taking the antiderivative of f prime, which will be f of x now. So we have to take the antiderivative of each expression on the right hand side. It's 4 times x to the power exponent plus 1 over exponent plus 1 plus 3 x to the power exponent plus 1 over exponent plus 1, 4 x to the exponent plus 1 exponent plus 1, and then c, antiderivative of c is cx plus d. So that will be x to the power 4 plus x cubed minus 2x squared plus 6x plus cx plus d. That is f of x. Now we have two conditions. Now f of x has got two unknowns c and d. For that we are given the two conditions. Let's use the first initial condition, which is f of 0 equal to 4. So as we said earlier, when x equal to 0, y equal to 4. So x equal to 0 and y equal to 4, or f of x equal to 4. So that's what this means. So substitute x equal to 0 and f of x equal to 4 in 2. So you get 4 equal to f at 0, which is equal to 0 to the power 4, 0 cube minus 2 0 square plus c times 0 plus d. So 4 equal to all the terms are 0 except d. So you already get one value of the unknown, which is d equal to 4 in step 2. So now substitute this d in 2. So what do we get? F of x equal to x to the power 4 plus x cube minus 2x squared plus cx. What is d? D equal to 4. So from what we have got, you can call it C3 maybe. Now we have to find out one more constant C here. For that, we are given one more condition in the problem, f at 1 equal to 1. So f at 1 equal to 1. Use f at 1 equal to 1. What does that mean? X equal to 1, y equal to 1 also, right? Y equal to 1 also. So use that condition here. So substitute x equal to 1 and f of x equal to 1 in N4. So you get 1 equal to f at 1. So we are replacing all the x values with 1. It's 1 to the power 4 plus 1 cube minus 2 times 1 square plus c times 1 plus 4. It's 1 plus 1, 2 minus 2 plus c plus 4. So on the left hand side, it's 1. So if you isolate c, it becomes 1 minus 4, which is equal to negative 3. Or c equal to negative 3. So we got the value of c, we got the value of d as well. So now we have to write down the function f involving the constants c and d with the values replaced by negative 3 and 4. So what is, the question is to find f of x, right? The answer f of x will be equal to x to the power 4 plus x cube minus 2x square plus cx, c is replaced by negative 3 plus 4. This is from 4. We only plugged in the values of c and d here. So in this problem, you are given only the values of f, initial values of f at 2 specific points. So you have to do, you have to get to the step where you have c and also one more time differentiate. That will throw a d, 2 constants, and you take these 2 initial conditions of f and substitute them to get the values of c and d. When you write the final answer, it should be the answer for the entire f of x with the constant c and d replaced by the values that you found out. So there are some additional problems in this exercise here. You notice that there are many problems that are already done in the section videos. So please refer to my section videos. When I say section videos for section 4.9. See this problem, practice test number 21 is done in the video, 40 is done in the video, practice test 49 is done in the video, practice test practice final 67 and 77 are all done in the videos. Okay, so you may want to refer to those videos for more practice on these types of problems. For this purpose of the video, we will do number 13 or number 14, number 13. Okay, let's do number 13. Find the most general antiderivative of the function. Check your answer by differentiation. Check your answer by differentiation. So what is number 13? So it says it's 1 over 5 minus 2 over x. One over 5 minus 2 over x. So now the question is, what is the antiderivative? We'll start off with the specific antiderivative. Integral of a constant. 1 over 5 is a constant. You treat this like any other constant. So what is the antiderivative? 1 over 5x. A constant, it is that times multiplied by x. Then this 2 over x can be written as 2 times 1 over x. Right? So 2 can be taken out. Then it's antiderivative of 1 over x. So what is antiderivative of 1 over x that we saw? It is equal to ln of absolute x. So it is 2 times ln of absolute x. So if we want to check whether our answer is right, so because it's a general antiderivative, we'll add a c. So if you differentiate this function, it is 1 over 5 times x. So derivative of that is 1 over 5 minus 2 ln of absolute x, that will be 1 over x, plus derivative of a constant, which is equal to 0. So that you notice that the derivative of our answer gives us the original function. So that clearly verifies that uppercase f is the antiderivative of lowercase f. All right. Let's try another problem. Probably number 36 or 62. We'll try number 62. So in this problem, it says the particle is moving with the given data. Find the position of the particle. A of t equal to 3 cosine t minus 2 sine t, and s at 0 equal to 0, and v at 0 equal to 4. So let's start off with A of t. A of t stands for the acceleration. So in a particle motion, you know that position, when it is differentiated, you get the velocity, which is s prime t. When you differentiate the velocity, which will give you A of t, acceleration. So this direction is derivative. We'll go backwards now. So acceleration, if you do the antiderivative, what you get is the velocity. If you take the antiderivative of the velocity, you get the original function, position function. So this helps us here. So acceleration is what is given in our problem, which is nothing but the derivative of the velocity, which is equal to 3 cosine of t minus 2 sine of t. That is A of t. When I take the antiderivative, I'll be getting V of t, is antiderivative of A of t. So that is what we said. From A of t, if you take the antiderivative, you get V of t. So antiderivative of 3 cosine t. So 3 is a constant. Antiderivative of cosine t is sine of t. Then minus 2, you can take the constant out. Antiderivative of sine of t equal to negative cosine of t. Negative cosine of t. You may want to add a constant here. That is 3 sine t plus 2 cosine of t plus an additive constant for velocity. So in this particular problem, we have a relation given to find out the constant. The relation that is given is v at 0 equal to 4. So we will use that, v at 0 equal to 4. 4 equal to v at 0. So I'm replacing the t with 0. That is the input. So 3 sine of 0 plus 2 cosine of 0 plus c. So that will give us sine 0 is 0. So 2 cosine 0 is 1. So plus c. So 2 plus c equal to 4. Or what is c? C equal to 4 minus 2, which is equal to 2. So we got the constant c. You substitute that back into step 1 in v of t. So substituting c equal to 2 in step 1 for v of t. In 1 for v of t. we get V of t equal to 3 sine of t plus 2 cosine of t plus 2. I'm substituting this back into V of t. So now you have to again take the antiderivative to get S of t. So S of t is nothing but antiderivative of V of t. Okay. That's what we said. From V of t to S of t, you have to take the antiderivative. So S of t would be antiderivative of 3 sine t, which is negative 3 cosine of t, plus 2 antiderivative of 2 cosine t, which is 2 sine t, antiderivative of 2, which is 2t, plus an additive constant. Now we need to find out what this constant is. So for that, you are given a condition that S of 0 equal to 0. S of 0 equal to 0 here. So we use that 0 equal to S at 0. So that means you are substituting for t here, which is negative 3 cosine of 0 plus 2 sine 0 plus 2 times 0 plus t. So 0 equal to negative 3 times 1, cosine 0 equal to 1. Then 2 sine 0, 2 times 0, sine 0 is 0, plus 2 times 0 is 0, plus t. So we get 0 equal to negative 3 plus d, or d equal to 3. All we need to do is to substitute that back into S of t, because we are asked to find out what S of t is, which is the position function, the position of the particle, position at time t, is given by S of t equal to, so go back to the function where it has a d in it, then that will be negative 3 cosine of t plus 2 sine of t plus 2t plus d, but d equal to 3. So in a particle motion, you should always remember this. If you are going in the direction of position, velocity, acceleration, each time you will do the derivative. If you are going backwards, acceleration, velocity, and position, you will do antiderivative. Hope this video helps. Please watch the rest of the problems. There are many problems done in the section videos, as I said earlier. So check the videos for this section for all the problems that I have mentioned in this. These problems are done in the video. Then we will watch my next video on chapter 5.